Hello everyone, I am Nikhil. I am from Sri Venkateswara College of Engineering. I would like to explain the course of Design and Analysis of Algorithm, and the course code is 21CS43, and I would like to explain the topic about insertion sort. Let's move on to the insertion sort. And insertion sort is a simple sorting algorithm that works on a similar to way you can sort the play cards in your hands. The array is a virtual split into a sorted and the unsorted part. The values from the unsorted parts are picked and placed at their current position in the sorted plat. And to sort an array of the size, the n is an ascending order. They iterate over the array and compare the current elements to its predecessors. If the key element is smaller than its predecessors, compare it to the before element and move into the greater element one position up to take space from the swapped element. Let's move on to the code for insertion sort. The void insert sort of an int array, int length, where the int j, temp for I, int I is equals to 0 and I is less than length and I plus plus and j plus is equals to I, while j is greater than 0 and array of j is less than array of j minus 1. And the temp is equals to array of j and the array of I is equals to array of j minus 1. The array of j minus 1 is equals to temp and j minus minus. Let's move on to the working of the insertion sort algorithm. Consider an element and the array of 12, 11, 13, 5, and 6. We have to list it with an order 12, 11, 13, 5, 6, and we can initially that first two elements of the array are compared with the insertion sort and the comparing with the insertion sort is and the sorted elements is 12, 11, 13, 5, and 6. Here the 12 is the greater than 11, hence they are not in an ascending order and the 12 is not in its correct position. Those that swap the 11 and 12. So for now 11 is stored in the sorted subarray and the array list is 11, 12, 13, 5 and 6. Now we can move the next two elements and compare them and the sorted elements are 11, 12, 13, and 5, and 6. The both 5 and 13 are present at their correct place, so swap them. And the elements are array elements are the 11, 12, 5, 13, and 6. After the swapping the elements, 12 and 5 are not sorted. Those swap again. And the sorted elements are 11, 5, 12, 13, and 6. And here again, 11 and 5 are not sorted. Hence, they swap again. And the sorted elements are 5, 11, 12, 13, and 6. And here it's at a correct position. Now the elements which are present in the sorted subarrays that are 5, 11 and 12. It's moving to the next two elements that are 13 and the 6. And then the elements are 5, 11, 12, 13, 6. Can clearly they are not a sorted, thus the perform the swap between them both. And the sorted elements are 5, 11, 12, and 6 and 13. Now 6 is smaller than the 12, hence the swap again. And the sorted elements are 5, 11, 6, 12, and 13. Here also swapping makes 11 and 6 are unsorted. Hence the swap again and the sorted elements are 5, 6, 11, 12, and 13. And Finally, the array is completed, sorted, and the sorted elements are sorting with the ascending order. Let's move on to the time complexity. Time complexity is then how much time takes to complete the execution of the program, and the time complexity of an insertion sort is big O of n square. And the space complexity, the space complexity is in how much space takes to complete the execution of the program, and the auxiliary space is big O of 1. And the complexity that can analysis of the insertion sort, like time complexity that can have a insertion sort, and the worst case time complexity of the insertion sort is big O of n square. uh, the where average case of the complexity of the insertion sort is, and we go of n square, and this time the complexity is the best case in big O of n. The space complexity of an insertion sort is, and the space complexity of an insertion sort that can takes to place to execution of the program. The auxiliary space complexity of an insertion sort is big O of 1. Let's move on to the characteristics of insertion sort, and this is an algorithm. So one of the simplest algorithm, where which is a simple implementation, and basically the insertion sort is a efficient for small data values, and the insertion sort is adaptive in nature, and that is it is appropriate for the data sets that are already partially sorted. So thank you for watching this video.